Thank you, Artis, for the introduction. My name is Alex. I'm Zabbix Chemical Support Engineer, and today we're going to talk about how to secure your connections to the Postgres database, to your Postgres backend. But before we actually move on to that, so let's take a look at security in Zabbix as it is. So if you already work with Zabbix, and I hope you did, you might know that Zabbix actually supports secure, or in other words, encrypted connections between all the components that you actually use or can use in Zabbix, depending on what exactly and how exactly you monitor. So this simple schema actually shows us what exactly can be secured. So as you can see, connections between Zabbix server and the database, or between frontend and the database, or between Zabbix agents and Zabbix proxies and Zabbix servers and even command line utilities can be encrypted to make sure if anyone at any moment, intercepts your data, you will be still safe, since they won't be able to actually see the real data, see what is going on, because it will be encrypted. But let's talk about specifically securing the database connection. So we are going to take a look at this part where we actually make connection between Zabbix frontend and the Zabbix database secure. And why is that important? Well, for the simplest reason, because all the sensitive, and not only sensitive information, like let's say maybe credentials, maybe community names for your SNMP devices, maybe again some specific URLs that you don't want to share with anyone, are stored in the database by default, or maybe again just the data you actually collect. So all the historical values, all the numbers, all the strings, all the log lines, and so on also are kept in the database. So that's a lot. That's basically everything. Again, by looking into that information, somebody can actually make a full picture of what is going on with your infrastructure. And of course, we do not want that. Our infrastructure is our infrastructure, and the only people we are planning to share this information with is, of course, our colleagues most of the time. But again, it depends. But definitely, we do not want to share it with some random person who actually, got into our traffic and somehow tried to get the data from it. So how is it encrypted in Zabbix? It's actually pretty simple, but very efficient. So what we need to use certificates, the so-called SSL certificates, which will be using TLS protocol to, again, exchange the data, to make handshakes, to confirm who is connecting to who. So is that really a proper Zabbix server? Is that really the database that it should connect to? And basically, are they exchanging the proper data? For example, if somebody even tries to spoof the data, maybe. So Zabbix supports it, and as you can see, the schema is quite simple. So we will encrypt connection between Zabbix server and the database using TLS protocol, and the same goes for the database and the web server or the front end, to make sure when users, enter some information in the front end, create something in the front end, it will also go to the database in a secure way. And when they will decide they want to view, some graphs, some specific values, it will also be passed in a secure way. The only limitation to that, but it's not a Zabbix limitation, it's a database level limitation. Encryption is not possible using Unix socket connections, meaning that, in short, you will need to have your database and your Zabbix server and frontend on separate machines. Zabbix server and Zabbix frontend can be, of course, on one machine and database on the other, but still at least two machines will be required to make sure the connection is properly secured. But again, it's always a good idea to use two machines, for the simplest reason being you will get more flexibility in terms of actually scaling later on. When your environment will grow, when your number of devices and metrics will grow, it will be simpler to add some more resources, for example, to the database. So how does that work? Well, what we will need is, of course, a CA, or a certificate authority. Basically, the authority that gives the system, gives your system components the certificate and actually signs them, basically stating that this is a legitimate certificate which can be used and which can be, the main thing is, of course, trusted. And what is generated using CA is, of course, the client certificate and the key, which is basically making sure that whoever makes the connection, so the client who makes the connection, is somebody that can make that connection in a secure way. But it's optional. If your goal, again, is not verifying who is connecting, but just encrypting the data, it's actually not required. And the second part is the database server certificate and the key that will be, again, used in our case by Postgres to actually encrypt the data. And this one is absolutely obligatory to actually do that. And later on, we will see how we can configure that and use that. And if we want to go on really advanced level, so the proper security where we actually verify who is connecting and is it connecting to a proper database. And again, if the certificates were actually issued by the same certificate authority and are valid, then we will also require the CA certificate. So both Zabbix and database can actually verify that, yes, those are trusted entities. I can trust them. I can allow them to connect to each other and exchange the data and encrypt the data. Currently in Zabbix, there are 3 modes overall how to make the connection secure. So first one is the simplest one, is just required. So basically connection should be, again, using TLS, and that's it. So data will be encrypted, but there will be no verification like who is making the connection, is it the correct certificate or not, and so on, which is, a simple and efficient way to, for example, encrypt the data that is exchanged, let's say, in development. Especially since you can use self-signed certificates for that, absolutely, why not? And it will take you roughly 5 or less minutes to actually encrypt the data and feel a bit more secure in terms of your data. Other option is verify CA. So basically verify the database certificate. Was it issued by a proper certificate authority that you trust? Again, this can be also, if you're self-signing the certificates, it can be your own authority from your own device, or it can be, again, an authority, globally trusted authority, and you can use those. But Let's Encrypt also will work. Why not? And then verify full, when we actually verify that DB host parameter in Zabbix server configuration is actually matching the CN field in the certificate, the one that is usually referred to as common name, but in this case can be actually referred to, I would say, as a host name. Why? Because it should be in a DB host, so it will be used to actually make the connection. And then again, Zabbix will make a full check, including the database, who is connecting to who. And not only Zabbix server will need to be configured, of course, since if we're going the encryption way, it's absolutely proper to also make connections from the front end encrypted too. So we will need to go to the front end configuration, or again, if it's a new installation, we can do it from the start by using the setup wizard and actually specified right there. But those options, again, will be visible only if you have your front end and the database on separate machines, since again, encryption using the same socket, so basically when everything is installed on the same machine, is not possible, so it won't be working. So why even give the option, of course, to try and configure it? So let's take a look at how exactly can we actually configure it using PostgreSQL. So in this setup, I used quite, I would say, the most popular type of setups I see on an everyday basis. So I had to CentOS 8 server, but again, any preferred Linux will work. So use what you like the most or trust the most. So Ubuntu, Oracle, Linux, again, something else, something less popular, something more popular, it's up to you. Just use what you like and know the best. We will need, of course, the front end and the Zabbix to have something to configure and something to monitor things later on. We will need one Postgres And again, this Postgres will need to be on a separate server, our Postgres database. So I use the newest release, the PostgreSQL 14, but it will work the same way with PostgreSQL 13 or PostgreSQL 12. But of course, it's always a good idea to use the latest release, since again, it will usually provide you not only more options, it usually is more performant than, again, older releases. In my case, frontend and the Zabbix server are also the CA server or certificate authorities, since I will be using self-signed certificates, but it's up to you who to choose as a CA. You can even, again, make a third machine if you would like to. And what's really important, make sure to use proper host names or DNS when you will be configuring your Zabbix server and generating the certificates themselves. Since again, as you remember, we will need to provide those in the Zabbix server configuration. So this time, it's not a fresh install. This one assumes that you actually installed Zabbix, you have connected it to the PostgreSQL, but you use not encrypted connections and you want to change it. So what do you need to do to actually change it? First, you will need to become a CA or a certificate authority. So on one of the preferred servers, again, Zabbix server, database server, third server, create a directory for certificates. As simple as, again, make dir -p, and for example, etc CA certs. But again, if you want to go some other directory, it's up to you. Go into that directory and create the CA certificate while filling in the required fields. So as you can see, it will ask you to provide the country name, the state or province name, if you wish, locality name, organization name, which are all important if you will use it in your company, but not really, obligatory to be true if you're using self-signed certificates. What's really important is the common name in case you will be using it, especially for connections. So in my case, it's as simple as Zabbix-CA, Zabbix cert, but again, you can use whatever you like or use in the actual production using, again, your naming policy. So we have a CA, and that means we can create certificates and we can sign them. That's why you need to become a CA or certificate authority. So on the same server where you have your CA certificate, you will need to create the certificate for the database and then sign it. So again, it basically will be signed by your CA, so you actually created and signed the certificate. So we are using in this command the industry standard of a key, so 2048 symbols. Days in this case is 10 years, so 10 years a bit maybe too much. Certificates should be generated more often, but it's up to you. So use something which environment requires. If it's dev, of course, 10 years, why not? If it's production, then well, make sure to update certificates at least on a yearly basis, as they usually are. And then again, specify that you need the server key and that you are making the request. So generate it, and then of course, sign it using X509, which is the usual, again, industry standard, I would say, of a model to signing and creating certificates. And as you can see, we specified that the CA that will be used to sign the certificate is our previously generated CA PEM file. The key will be right here. And again, we set it for our Postgres server certificate. Again, we will need to fill in all the data for who is basically receiving this certificate. And as you can see in this case, the one who is receiving it and will be using it is the Zabbix database, our Postgres database. So we specify zabbix-db.zabbix.cert. And this is really important. Remember that we will use it later. We will get back to that. Since again, host name, and this will be our database server host name. So now we have, again, certificates for our Postgres. Upload those certificates on your Postgres database server. So basically use an SCP, use FTP, download, upload, use, again, any way you prefer, but just make sure that they end up in the Postgres data directory, which, again, in default installation case was varlib PostgreSQL 14 data. Then, of course, secure them. So make sure only Postgres can actually read them, because again, nobody else needs to. In this case, only Postgres will be using them. And then go to PostgreSQL conf file, which should be again located basically in the same directory, and specify that now encryption is on, and specify the names of your certificate and the key. And this is really important. Postgres do not have, let's say, some kind of default certificates just lying around in the same directory. So you will need to put them there. You will need to make them readable for Postgres only, and you will need to make SSL on. Then stop Zabbix server, and this is really important, because otherwise, if you will do the restart first, Zabbix will try to reconnect, which will not happen, and Zabbix will just knock on the Postgres door until, well, you will basically need to give it a proper no until it stops. So stop Zabbix server first, and restart PostgreSQL to actually apply the changes that you did with configuration files. And then you will need to update Zabbix server configuration in a very simple way. So just go to the Zabbix server configuration file, find the parameter called dbtlsconnect, which again specifies for Zabbix how to connect to the database, and set it to required. So remember those options we've seen earlier? This is the first one, the simplest one. Just connection should be encrypted. And then start your Zabbix server. Don't forget to edit the frontend file. And it's as simple as set the DB encryption to the true. And just make sure verify host stays the same as false, because in this case, we do not verify the host. We just make the connection encrypted. That's done. And you can go into your Postgres. So just make sudo u Postgres PSQL. You can use any other user. You can use Zabbix user if you have one. And just again, select that from pgstat.ssl, and you will see that all connections from Zabbix are now encrypted. But, and there is a small, but can be a really important but in this installation, since as you can see, there's no client DN, no client serial, no issuer DN. So basically, Postgres accepts the connection. Now it's encrypted. It works fully. Data is exchanged in an encrypted way, but there's no verification. Who issued the certificate? Is it a valid certificate? Should you be using it? Nobody knows except you, of course, since you generated it. So how can we actually improve the secure connections in this case? And again, we can, and it's also relatively simple. So this time around, we will need to create a database client certificate and sign it. So the client in this case is Zabbix. The client is the one who is making the connection. So basically, we are generating right here the certificate for the Zabbix itself. And again, we specified that this will be the PostgreSQL-client.zabbix.cert. As simple as that. We use the same command, as you can see. It's again the industry standard. We sign it, which is important, with the same CA. Because again, for both sides to verify that they are valid, they need to be issued by the same CA, so certificate authority. So make sure you use the same CA files to actually sign the certificate, and then verify that you did it correctly. That's really important because, again, if this command will fail, it means that in the end, your connection will not work because, well, not Zabbix, not Postgres will be able to verify it. They will see that something is wrong, maybe an improper CA was used and so on. And they will not be able to accept this connection because, you know, invalid certificate authority gave you the certificate. So if you see the output as PostgreSQL Server cert, we are using the same that we generated previously. So if you want to go, you know, using the slides later on and create a proper validated certificates, just follow them without interventions. And we see that they're both are valid, which is great. So now we will need to upload CA file, so certificate authority file, the same CA PAM, which we use to sign them, to PostgreSQL server directory. So again, Postgres have the possibility to actually check who should be CA, who should be issuing certificates, and then validate those certificates. So we upload them, we secure them. Again, only Postgres basically should be reading them. If somebody will need to replace them, that should be a root user, definitely. And then we update the PostgreSQL configuration once more. So once more, we are going to PostgreSQL configuration file. And this time we add a new line, SSL CA file should be CA pen. So our certificate authority file. And we also add something else. So this time we also go to pg hba-conf, which, as you probably know, is responsible for configuring who is allowed and in which way to connect to the database. And if previously it was as simple, for example, as host, all, IP of the Zabbix server, and the way that you accept the connection, so in this case, the usual password. This time around, we are adding the line host SSL, which already implies that that should be an SSL connection. And we also specify that Postgres should verify the certificate authority, meaning that Postgres should check who actually issued this certificate. Is it the same CA that we have in Postgres configuration? So we've done that. Now we can stop Zabbix server and we can restart PostgreSQL to apply our changes. So from Postgres side, we're basically finished, but not from the Zabbix side. Zabbix still needs his certificates, which we generated, the client certificates. So we will make on the Zabbix server a directory for certificates. Again, can be whatever you like the most. I'm making etc Zabbix SSL. I'm copying certificates, which we generated for the client, into that directory. And then I make, again, the owner Zabbix. So only Zabbix can actually use those files. As you can see, even though we can add something else to the directory, the files themselves are read-only. And check the output. You should have the CA file in it and the client certificate and the key files. And again, they should be owned by Zabbix and they should be read-only. After that, update the Zabbix configuration. But before you do, check your host's file. So check that you have your database server IP by the host name, ZabbixDB, Zabbix cert, just as it was in the certificates as we added it to it earlier. So when you've checked and yes, it's the same, then make sure it's the same as DB host in Zabbix server configuration file. So again, it should be ZabbixDB, Zabbix cert. So if you use DNS, of course, you wouldn't check in here, but still. Host name and DB host must match the one that is in the certificate. That's really, really important, or connection will fail because Zabbix will basically think that, again, I'm connecting to a wrong host, not the one that's specified in the certificate. So you checked it, it's all fine. Then, of course, update the configuration. This time, db-tls connect mode becomes verify full. So make the full verification, check the certificate authority, check who issued the certificate, and am I connecting to the right DB? And then provide Zabbix with the files, just as you did with Postgres. So who is the certificate authority who issues and signs certificates? What is my certificate file and what the key should I use? And then restart Zabbix server. And at this point, your connections between Zabbix server and the Postgres are encrypted and also verified from, well, basically any certificate site possible. But we still need to configure frontend. So frontend will also need those certificates. So create another directory for your frontend. In my case, again, that was Apache. Apache cannot read, any directory that it wills at any moment. So I've added one for it specifically. I copied all the files, all the certificate files, all the client certificate files into it, made the owner Apache, and then I edited the front-end configuration. So I specified that DB server should be, again, zabbix-db.zabbix.cert. And this time I also added the key file, the cert file, and the CA file. And also specified that verified host should be true. So now frontend also should verify that he's connected to the right database. And again, if it's a fresh installation, you will be able to do the same thing from the setup wizard, from the front-end setup wizard. If you wish, you can even delete this file and reconfigure the front-end. You will not lose any settings from it. If you like, let's say, to work with a more visualized approach, then why not use it? And then again, go to your, again, Zabbix, copy, execute the pg status cell, and make sure the output is with the cipher, making sure the connection is okay. And now we see who is connecting and who issued the certificate. So that's about it. That's how simple it is done. But there are some considerations you should keep in mind when you are going the secure encrypted way. So all the Zabbix processes that will be connecting to the database will use encryption. For now, it's still, in 5.0, that's still quite a lot of processes. But again, in 5.4, it's a bit lower. In 6.0, it will be even lower. So it will improve. Of course, use or try to use the newest DB engine version possible. Like in my case, for example, the PostgreSQL 14. Usually, most case, newer versions perform better than the older ones during the optimizations and updates. The longer the key, the more it will affect the encryption speed and the overall handshake. So even though the industry standard is 2048 symbols, you might consider, if you're, let's say, low on resources and you cannot just, pump in all the hardware and the fastest fiber optics you need in, then maybe you can opt for using, again, 512 symbols long key. It will be faster and it will still require, well, a whole team of people to actually try and crack it. It's still, again, not verified that anyone actually did it, but it's considered to be not, secure enough. But again, for development, why not? You can definitely use it. Use the newest TLS protocol version. So TLS 1.3 will be faster than older protocols. The simplest explanation for that is, for example, TLS 1.2 needs around 6 steps to make a proper handshake, to verify who is connecting to who, to share the certificates, group the data, and so on. With TLS 1.3, it's only 4 steps. And in general, only because of this, TLS 1.3 will be 30% faster than TLS 1.2. And cipher suits used for encryption also affect performance. So there are ciphers that actually make the, again, overall length of the handshake and encryption faster. But because they're faster, sometimes they are considered to be, again, less secure. While the ones that actually take quite some time, considered to be more secure, but again, they take quite some time. So try to use, again, something in the middle. There are a lot of discussions where what you can use and what would be better. So thank you for your attention. Thank you for your time. And if you have any questions, I will be glad to answer them. And if not, then of course, just thank you for your time and attention again.
Thank you. I do have a question myself. You mentioned you were using PostgreSQL 14, right?
Exactly.
But if I'm looking, for example, at our requirements page, without partitioning, it says we can use Postgres 12 or newer, and I'm looking at version 5.4. With partitioning, it says version 13, and with timescale, it says, okay, with timescale, it does say 13.12 or newer. So not really sure. Question is Postgres 14, is it supported? Have you noticed any issues with it? Is it safe to use?
So I know in our requirements, it's still not mentioned because I'm pretty sure it was not tested just, on 200% as we usually do, but I have not noticed any issues. I've been, again, using it for quite some time. Not a long time. It wasn't released that long ago, but for a couple of weeks, and I haven't noticed any issues.
Have you tested with timescale or partitioning or anything like that?
With timescale, no, not yet, unfortunately. But with timescale, again, it's a good idea. I will definitely do it. But with timescale, you need to be, expecting that something might go wrong, because even though Postgres and timescale are, I would say, quite friendly with each other, those are still I would say completely different things, and you need to keep that in mind and read release notes from both.
Have you played around with the cipher suits or cipher algorithms? Any experiences with which one is the fastest or maybe the slowest, which one to use or not to use?
I've played with them a bit, but unfortunately, I don't have, a proper
Benchmark,
scale to check it. So I didn't notice a real difference. But you can actually use a command line tool, OpenSSL, the same one that you use to create certificates, with an option verify, not verify, but to check the performance specifically. So it's possible, and you can make some benchmarks for that.